This is where the future takes flight. Behind me is the R-44, showcasing the next generation of aerospace engineering. While it might look ready for the skies, the truth is that keeping this stealth bomber operational is an incredibly complex and expensive process.
Telemetry shows 89.80. Record that immediately.
Confirmed. Reading taken.
And now it's shifting to 6980. Remarkable precision.
The scale of this operation is truly breathtaking. This fuselage component alone weighs several tons. Wow, look at that weld! It's flawless!
The assembly process combines human precision with advanced robotics, ensuring every connection point meets the strictest safety standards.
This section highlights the intricate internal structure, showcasing the complex wiring and the fuselage ribbing before the panels are attached.
We need to verify the alignment on panel 7 right here.
Schematics confirm the revised specifications.
Securing this section now.
Okay, panel secure on the left.
Confirmed on the right. Robot, engage sequence 2.
All right, hold it steady. A little to the right. Copy that, coming right. Perfect, bring it down slowly.
Ensure alignment is within tolerance before proceeding.
Copy that. Adjusting the starboard stabilizer now.
Steady, steady. Alignment looks correct. Secure the clamps.
Look at the consistency of that bead right there.
Yep. Impressive. The calibration seems to be holding steady.
Apply pressure slowly. Watch the torque.
It's holding steady at 60. Finalizing the lock.
All right, slowly lower it down.
Watch the alignment on the left side.
Looks good, hold it there.
The alignment on the starboard side looks good.
Confirmed. The torque specs are holding steady at 900 Newton meters.
Should align the feed. Hold steady while I torque the final bolt. It's holding firm.
The precision of this tool lets us bond the components seamlessly, which is critical for maintaining the aircraft's low observable characteristics.
This textured carbon fiber isn't just for show. It's integral to the stealth capabilities of the aircraft, absorbing radar waves.
All right, bring it down 5 more centimeters.
Watch the clearance on the starboard side.
Looks good, keep it steady.
Bring it down another few inches, slowly.
Copy that, watch the clearance on the left side.
Looks good, keep it steady.
All systems are currently reading green. The insulation appears structurally sound at this junction.
Confirm torque setting on panel access 7. Reading confirmed. Tolerance level is nominal.
The robot is currently finalizing the weave pattern on the leading edge. This specific composite is what gives the aircraft its unique stealth properties.
Scanning indicates full adhesion on panel 4 alpha. No anomalies detected in the substrate.
Check the alignment on the secondary strut.
It looks good from here, within tolerance.
Final torque check complete, pressure nominal.
Systems check is green. Requesting clearance.
It's still timing out. We're getting incomplete responses. Check the readings on line 4.
It's holding steady at 50 psi.
All right, log that and continue the sequence.
Approaching waypoint Charlie, altitude stable.
Check the hydraulic pressure on the main strut. Looks good, the readings are within tolerance.
As you can see here, the diagnostic tool reads 87.5 psi. We're checking the pressure on these main hydraulic.
Data verification is complete. All systems are nominal.
Thermal scan shows no anomalies. Proceeding to the next section.
Control, this is Flight 75. I show a fluctuation on the starboard actuator. Adjusting parameters now.
This is where the magic happens. The electronic control module dictates everything from flight stabilization to stealth optimization.
The heartbeat display is showing a steady rhythm, confirming the ECM stabilization we achieved yesterday. We monitor the thermal dynamics closely. Once the system stabilizes, the analytical grids confirm full operational status.
Pressure holding steady at 50 psi. Seal integrity confirmed. We are good to proceed to Section 4.
Seal pressure is confirmed at optimal levels. Initiating the landing gear cycle now. Extension is smooth, and we are showing full retraction.
Check the ECM molute status.
Reading 100% operational across the board, good to go.
Integrating the ECM molute system demands meticulous attention to detail. Every connection is critical to mission success.
Flap sequence initiated. Data looks nominal across the board.
Copy that. Stabilizers are within tolerance.
Maintaining the radar-absorbent material is crucial. It requires precision application and constant monitoring by the team.
We need to adjust the tension on the forward port chain.
Copy. Initiating slow retraction now.
Okay, I'm seeing some heat stress right at the seam.
Roger that. Proceeding with the composite application now. Keep the tolerances tight. To maintain the stealth capabilities of this aircraft, the radar-absorbent material must be cleaned with absolute precision before every flight.
Polish is optimal. We are cleared for coating.
Clearance checked. Moving forward at 2 meters per minute.
Clear on the left, maintaining 2 knots. Copy that.
Final torque sequence is complete on the main gear.
This red tag indicates a safety pin that must be removed before flight operations.
Systems check complete, requesting taxi clearance.
Easy on the chain. All right, it's clear.
All right, steady push now. Keep it aligned with the yellow line.
Roger that. Watching the clearance on the right.
Powering up the tug, slow and steady.